When we think about making AI smarter, we usually think about feeding it more and more data. But what if the real secret to intelligence isn't just about remembering more, but about knowing what to forget? Today, we're diving into a fascinating new framework called SEDM that's built on that very idea. So, picture this. On one side, you've got what we can call the AI hoarder. This is kind of the default for a lot of systems right now. It saves absolutely everything it comes across, and while that sounds like a good thing, it gets bogged down, slow, and confused by all the noise. But on the other side, you have the goal, the smart learner. This AI doesn't just save things, it curates its knowledge. It gets faster and way smarter over time. And bridging that gap is exactly what CDM is designed to do. All right, so let's really dig into this AI memory problem, because it's a bit counterintuitive. Why is piling on more memory not always the best strategy? Well, think about an AI agent working on a big, long-term project. It's constantly collecting info, but a huge chunk of that is just junk, useless noise. This hoarding leads to some serious problems. First, the good stuff gets drowned out by the bad. The memory just keeps growing and growing, which, you can imagine, sends the computational costs through the roof. And here's the real kicker. All of this can actually make the AI make worse decisions, not better ones. Okay, so that's the problem. And the solution? Well, that's where SEM comes in. Instead of a messy digital attic, I want you to think of SEM as a super smart, perfectly organized librarian for the AI's brain.
And here's the key idea. SEDM completely changes the game. It takes AI memory from being just a passive bucket, a database where you just dump stuff, and turns it into an active living system. It's constantly judging, sorting, and improving the information it holds, all to make the AI better and more efficient. So, how does this smart librarian actually do its job? It all boils down to 3 core principles, or pillars.
First, it acts like a really strict bouncer at a nightclub, deciding what information is even cool enough to get in. Second, it's an organizer, constantly rearranging the shelves to keep everything tidy and useful. And third, it's a translator, helping ideas from one subject connect with another. Let's start with that bouncer.
Okay, so this first step is called verifiable admission. Before any new tidbit of information, any new memory gets saved, SEDM makes it prove itself. It has to show it's actually valuable before it's allowed through the velvet rope. And it does this with a pretty clever tool called a self-contained execution context, or SCEC for short. Now just think of an SCEC like a perfect replay button for a task. It bundles up everything, the prompt, the code, the whole environment, so you can run the exact same task again and again for a clean, fair test.
So here's the test in action. It's basically a classic A/B test. Inside that SCIC, the system runs the task. That's condition A. Then it runs the exact same task again, but this time it gives the AI the new piece of information it's considering saving. That's condition B. Then it just compares the 2 outcomes.
And from that little experiment, SEDM spits out what it calls an admission score. This is super important because it's not just about whether the memory helped, it's about whether it helped enough to justify its cost. It looks at the improvement in the result, but it also subtracts the cost of using the memory, like extra processing time. If that final score is positive, great, the memory's in. If not, it gets tossed. No freeloaders here. All right, so the memory made it past the bouncer. It's in the club. Now what? Well, now the organizer gets to work. This is the self-scheduling memory controller, and it's all about keeping the memory library in perfect shape. See, when the AI needs to pull something from its memory, it's not just looking for the closest match. It uses this utility-aligned score. It's a simple but brilliant formula. It takes how similar a memory is to the current problem, and it multiplies that by the memory's proven usefulness, that score it got from the bouncer at the door. So the AI is always pulling up memories that are not only relevant, but are also proven winners. And this isn't a one-and-done thing. The librarian is always on duty. It's constantly updating the value of memories based on how well they work. It's also doing housekeeping, merging duplicate memories, throwing out things that are no longer useful, and even spotting patterns to create new general rules from specific examples. And that brings us to the final and maybe the most fascinating pillar, the translator. This is called cross-domain knowledge diffusion. A truly great librarian knows that an idea from the physics section might solve a problem in the history section. What SEDM does here is pretty cool. It takes a very specific memory and it creates a more general, abstract version of it. It basically pulls out the core lesson while removing all the nitty-gritty details. This makes the knowledge portable, so a lesson learned from a simple fact-checking task can suddenly be used to help with a totally different, super complex reasoning problem. Okay, so the theory is all well and good, right? The bouncer, the organizer, the translator, it all sounds great. But does it actually work in practice? Let's look at the results. So the researchers put it to the test. They took a fact-checking dataset called Fever. The AI with no memory at all, it scored a 57. Not great. The hoarder AI that just saves everything, well, it did better. It got a 62. But SEDM, our smart librarian, it blew them both away with a score of 66. That's a huge improvement in accuracy. But here is the absolute game changer. You might think getting that higher score would cost more, right? Nope. The hoarder AI burned through over 3.6 million tokens to get its score. SDM got its higher score using just under 2.5 million tokens. That is a massive savings. So you're getting better results for way less cost. That's the win-win. But then they ran a test on that translator ability, the knowledge diffusion. And this is where things get really mind-bending. They had the AI learn from one task and then tested it on a different one. And get this, when the AI learned from the simple fact-checking task, Fever, and was then tested on a complex reasoning task called Hotpot QA, it scored a 41. That's actually better than the 39 it scored when it learned and was tested on the same complex task. Let that sink in for a second. Knowledge gained from basic fact-checking made the AI better at complex reasoning than knowledge gained from the reasoning task itself. It's like learning your multiplication tables makes you better at calculus than just practicing calculus problems. It suggests a solid foundation of transferable factual knowledge is incredibly powerful. So, okay, let's step back from the numbers. What does all of this really mean for the future of AI? Why should we care? When you put it all together, the picture is pretty clear. This is a framework that makes AI more accurate and better at reasoning, while at the same time slashing the computational costs. It allows AI to take lessons from one area and apply them somewhere totally different. This isn't just a neat trick. It feels like a really crucial step toward building AI that can truly learn and adapt in a way that's actually sustainable. And that really leaves us with a fascinating thought to chew on. For all of human history, we've pretty much defined intelligence as the ability to accumulate knowledge. But if we're now successfully teaching AI the critical skill of forgetting, of carefully curating what really matters, what does that say about the next evolution of intelligence itself?